thank you for joining us today. I'm Nicole Chowdhury, and I've spent over 15 years in manufacturing and utilizing 3D printing to get products out on the market into your customers' hands as fast as possible. I want to create this webinar series to ease the crippling slowdown caused by COVID and the COVID bottleneck. We're here today to discuss 3D printing solution BigRep, professional grade large format printer. We will learn how to use BigRep to speed products to market and to even use BigRep parts for end-use applications. Marco will walk us through case studies that focus on applications and materials while we review geometries. Let me now turn this over to Marco, the head of BigRep product marketing. Thank you, Marco, for joining us today and teaching us more about BigRep capabilities and applications.
Thank you very much for having me. Thank Nick and Nicole for the introduction. I hope you can hear me well. So as mentioned before, my name is Marco Cristofori. I'm the head of product marketing here at BigRep. I wish I had as many years of experience in 3D printing as Nicole, but I have 5 years of experience and they're all in BigRep. I'm currently based in Berlin, where the headquarters of BigRep is. I started in the marketing department, but then I moved into consulting. So I work a lot with customers. And then I went back to marketing, to product marketing, because it was a natural way of developing. But today, as mentioned before, I will show you a lot of case studies, and I will give you basically quick introduction to various applications that can be used with large format 3D printing. Including material that we suggest to use, a couple of secrets maybe, but we don't go too much in details with applications, but this can open up, a bit of, it's a lot of seed for talks, and then people can use them to maybe get inspired, understand even better where large format, in this case FFF, can be used. Super quickly, introduction about BigRep. We are obviously a large format 3D printing manufacturer. The headquarters, as mentioned before, it's here in Berlin, so in Germany, but we have another office in Boston, Singapore, and recently we opened also in Shanghai, but we have several partners all over the world representing BigRep. And in the last years, in total, we collected more than 600 customers that decided to join the BigRep family, so they're using large format 3D printing for their application. We don't just develop obviously the printer, we have a full ecosystem around it. Obviously, we also develop our own extruder. We have our own filaments, which today we will discuss about a bit. But we are also an open system, so you can decide if you want to use our qualified materials or you can test your own. The machine will run anyway. And obviously also software, where we have, of course, our own slicer, but we have also other solutions that help you to connect multiple machines. So we try to build a full ecosystem to make sure that you're able to start manufacturing from day one. One of the thing I like more of BigRep, besides amazing technology, is actually their customer, the customers community. Because as mentioned, yes, we have 600 plus customers, but we call them super users because they're really like most of our customers are really happy and willing to share what they're doing. So we have dozens and dozens of customer success stories that we just keep publishing. And this, I think it's very valuable because again, open up a lot of people can figure out faster how large format FFF can be used maybe for their applications. In this case, for example, we picked 3 from 3 completely different industries where we have Andrew from UK, he's the co-founder of Fini16, and this guy has been trying to develop a new wheelchair, like completely like much lighter with a lot of functionality, but it was so costly for him at the beginning. It was super expensive to produce prototypes in carbon fiber because every time he wanted to make a new one, he had to go through a CNC, a milling of an aluminum mold, maybe like outsource it and then wait and then try to have the carbon fiber parts out of it, and then maybe it was working, maybe not. So the iteration was very long and very expensive until he figured that he could have done this with large format 3D printing, and this sped up radically his production and the first phase of development, and how he got funded and is in production, and he's very, very happy to support and to talk about BigRep. Mikkel is in Denmark. also is in Europe, is developing these large crane drones, and same things here. Also here for carbon fiber parts, he needed to do a lot of prototypes, a lot of iteration, and he figured that, you know, the beginning of a startup, mostly when you work like with vertical lifting, like drones or large scale drones, it really made sense to actually start do the prototyping in-house and use large format 3D printing. And then we have people like Riley, he's a technical manager, and Nicola Motors, who's also using large format 3D printing for the production aids, so like, you know, jigs, fixtures, but also prototypes. I give you an overview of this like table of application, let's say, where you can get already a first impression of where large format 3D printing can fit, again, in the production cycle, right? A product development cycle. So of course you have the first phase of prototyping whenever you need to build a new hardware, let's say large scale, large format. You have always a phase where you need to do probably a lot of iterations, and that's where all the design prototypes come in, or you see bottom left aerodynamic prototyping, but also functional prototyping. Or you start doing also prototyping with for carbon fiber parts. So you print actually the molds, and then you go slowly into the production aids where 3D printing can support. So there is a lot of like quality control. Again, there is molds, there is patterns, there is jigs, there is fixture, until you move also in the end production, right? So the end use part. Of course, if you do to mass produce the same part, obviously probably wouldn't choose to go with large format 3D printing. But if you have a small production, small batch production, or you go like the guys at Yamada with the water scooter we will see later for mass customization, then it makes sense to go with large format 3D printing. Or maybe you have spare parts, so it's again small amount that you just need to manufacture quickly and possibly locally. Let's try to start digging in. So the first one, we go with prototype. I will show you some example again from customers. Two of them here. We have two completely different walls, as you can imagine. On the left we have Zoller, which is a company in Germany that manufacture waste collection vehicles, and on the other side, on the right, we have Canyon, which is a pretty famous bicycle manufacturing company and designing company. So on the left side, Zoller is using large format 3D printing to actually iterate a lot of both big and small part for design iteration. So we're talking about prototype, functional prototype, where they can really speed up the production. Like, you know, if you can qualify your design faster, then your production will start faster as well. As you can see, for example, on the left side, the user at Zoller is holding a small part, which is something I will never get tired to keep repeating. It's large format 3D printer doesn't mean only large format part. With a large volume, you can also print smaller parts, but not only that, you can print several smaller parts, and all of them can be different, right? So you can print batch production of smaller parts, and you can really qualify a design in a matter of days. You can print 3, 4, 5, 6 different design of the part that you see the guy is holding, for example, and then just find the one that really qualifies and then move on. On the other side, of course, Canyon is more like large format. In this case, it's like bicycle frame, so they really fit the volume of the BigRep machines. We are talking about a 1 cubic meter, so 1 meter, 1 meter, 1 meter cubic, 1 meter, 1 meter, 1 meter build volume. And in that case, those frames are used again for qualification, for design fit check, or check also aerodynamicity or other factors that can support then the design decision, basically, to move to the next step. Material-wise, Canyon decided to go more with Pro HD, which is a qualified filament, an original filament from BigRep. It's very similar to PLA, but it's more temperature resistant. It's very easy to print. Support can be removed super fast and super easily. We suggest to use Pro HD as support of Pro HD, so you can use it as a breakaway support. And the material, again, it has a bit more resistance to impact than PLA. On the left side, Zoller decided to go with PLA, which we're probably all familiar with this filament. So it's a biopolymer, which is very easy to print. But in their case, probably they didn't need some of extra specification that maybe Pro HD had. So they decided to go simply with PLA. Plus, they have access to different colors, so they can also customize a bit more their prototypes. Moving on in the prototype world, we have on the right side Steelcase, which is a big furniture company, and they do not print and use furniture in their case, but again, we're talking about prototypes, so they can really evaluate shapes, design, looks, also the feeling, obviously, before they actually go in production. And this obviously makes you save a lot of time. If you consider that in the design world, also another thing is that you want to really keep your design in-house before you release a new furniture, because obviously you don't want people to copy it. It's a big benefit to be able to prototype with your own machine locally, so you can keep your design idea in-house, which of course it's the same for maybe like automotive companies or other companies where you want to protect your IPs. On the left side is something we developed in-house with the Now Lab, which is the consulting department of BigRep. The Nera e-bike, it's a fully 3D printed e-motorcycle. Obviously, it's a prototype. It's polymer. We're talking about plastic. But here, what we wanted to show is really like the flexibility and the agility that you can get by integrating large format 3D printing in your production. This full e-bike was basically from the beginning when we start sketching it till we actually had it run, because it's a functional one. It took 12 weeks. So we're talking about 3 months. So the time, it's really shrinked. If you consider or think if you are in this field and you can get an idea of how long it will take you to prototype such a piece, let's say with other manufacturing technologies, where you probably will need to also outsource a lot of parts, it definitely much more than 3 months and much more cost effective. So this was totally manufactured in-house. Everything is 3D printed beside the electronic components, obviously, so battery and the motors and the control system, which is everything integrated inside, but that's not printed, but everything else is printed. And we use as many filament of BigRep we had in-house just to show the capability. So the main body is Pro HD, which is the filament we discussed before. So it's more resistant than PLA, and it was also a bit more flexible, let's say, so it helps a lot for to hold the full thing together. We use TPU for the tires, the airless tires, and also a bumper that is in between the two bodies. So actually they are kind of shock absorbing. PTG for transparent surfaces like lights, etc. So we could have the lights pass through. And then we use PLA for the details to add colors. In that case was the blue PLA. But we have other versions that are red, orange. So we use PLA for more the decoration. So again, because you have the freedom of color choice, right? Which we have, which we don't have with other filament. So prototypes is obviously affecting every industry, and it really can help if you need to manufacture these large format hardwares or several smaller parts. The second industry, let's say, or application where large format can really help, obviously is production aid. So you already have a production running, and you have a shop floor where the production happens in your factory, and several things happens in that shop floor. Obviously, there is quality check, there is control, there is several steps where the parts needs to go through, and there is where also large format 3D printing can help. So there are several stations, let's say, or phases in the production where our customers are currently using our printers. One, for example, is on the left. You see WAT, but they're also located in Germany. It's a supplier, so they basically manufacture these welded steel frames for cars, obviously. But these frames needs to go through a quality check that requires basically an analysis of specific holes that they need to be of a specific diameters. So they manufacture several large format jigs and fixture. They call them smart fixture, in that case, smart fixtures, because they also add, as you can see, some of the details. There are several probes that they were able to integrate in the printed part, which helps them to qualify all the parts. So basically now the user can just hold the fixture, put it in place, they fit something in the hole, and then the probe gives green light or red light, so move forward or not. It's a very big part. I don't know if you can see a bit on the left. You can see the hand of the worker, and if you know a bit of CNC and maybe the aluminum wall, and you can quickly cost estimate in your head how much it would cost to manufacture such a big part. We're talking about probably 80 by 80 centimeter by 20. CNC it in aluminum, it would be very expensive. Plus, some of the undercut wouldn't be possible, and definitely heavier. So that was another thing. So not only that you produce it in house, it's also lighter and it's cheaper. So you get all the benefits. Same as Ford, where they basically decided to invest in BigRep. They have a BigRep 1 and a BigRep Pro, and they use our printers to manufacture alignment jigs. Obviously, jigs can be used for several things like placing logos or other things. In this case, was probably to check that the frame was the actual frame had the right dimensions and the hole were in the right place. And yet the production of this jig, it decreased, the cost of production decreased by 76%. But same as WAT, there is also another factor which the part is much lighter. Here we mentioned different filament from before. We have high temp and high temp CF. High temp, it's another qualified filament from the BigRep portfolio. It's a Pro HD evolved in a way. It's a Pro HD that resists much higher temperature. We're still talking about an open machine. So of course we are not talking about peak or ultem or those filament, but high temp can resist up to 115 degrees Celsius. And there is the fiber field brother, which is the high temp CF, which has the same temperature resistance, but obviously has benefits thanks to those chopped fibers that are inside, carbon fiber, which makes the material, let's say the parts are stronger. And obviously the accuracy is higher because the part doesn't tend to shrink because of the fiber, plus the adhesion to the bed is much higher. So of course you can decide which filament you need accordingly with your application. While high temp, it's a bit more flexible. High temp CF, it's more accurate and it's a bit stronger. In both examples, we mentioned also BDOH, which is our water-soluble solutions filament. It's what we use for support. When you want your supported surface to be very clean, we suggest to use water-soluble. If you are not really mind about the surface that is supported, because it's not about quality but functionality, then you can have breakaway support. BDOH can also be very useful for other things, like if you have, of course, support that you cannot reach and you cannot remove it by yourself, so water can reach it easier, then it's also strongly suggested. I will quickly show other production aids that we have as an example. Of course, you can print a lot of like handheld alignment jig, as you can see on the top left. These are big ones that you can see, like the one we mentioned before. The one that is in the pictures is a 1.20 m because it takes the diagonal of the BigRep Pro. End of arm robotic gripper. We have seen a lot of those around that can be 3D printed, so you can really customize your robot gripper. Obviously, Pokayoke, assembly jigs, welding and milling fixture that can be customized, soft jaws as well. You can use TPU, obviously, which is a bit softer material, let's say, to design a custom soft jaw that can hold your part and then you can clamp it without actually breaking it or affecting it. Of course, then there is other minor, let's say, things like tool holders or shadow boards. It's very interesting how our customers do, like WAT, for example. Again, they have a 3D printer, a BigRep 1 inside their shop floor, and they have one guy that his job is basically every day he goes around the production floor and checks out what can be improved. Then goes on his laptop, he designs something, he prints it the day after he tests it, and if they see an improvement in the time or in the quality, they implement it. So it's very, very agile, which is very interesting. And then, of course, there is a full quality insurance also application. So as we saw before, the go, no-go gauge, and we have inspection fixtures, coordinate measuring machine fixture, like Nicola is using, so you can host, you can print parts that host, for example, CNC machine, so then you can actually scan them and check if they fit or if the accuracy is the right one, or the inspection fixture, as you can see on the left from Ford, that is a full, basically it's a car door opening, so they can actually check if everything is, if the structure fit. The next one we go to form and molds, which is forms and mold, of course, is a huge one. There are several industries, but also several applications that can be manufactured with form and molds. Also here I will have a lot of pictures and an example from customers. Let's start from the one that's, let's say, is the most requested, which is obviously carbon fiber reinforced plastic molds and pattern. Manufacturing carbon fiber parts right now, it's very expensive. There are several ways. Obviously, if you go in mass productions or if you want very high quality parts for mass production, there is nothing that can replace well CNC aluminum part. But there are other situations where that one would be probably too expensive, which is either when you need to manufacture a small amount of very high quality carbon fiber parts, or when you just need to manufacture maybe a big amount, but that it doesn't matter if the quality is high. It's more like for fit check or for prototyping. And here are two examples. Xenons is a customer of ours in UK. They customize cars, which means customer go there with their car. They ask for some customization. The guys there use a 3D scanner to scan the existing part. They go on their software. They do some magic. They print, and then out of the print they will make a carbon fiber parts. I will show you later a bit more in detail how. On the right side instead is more air flight, as mentioned before. So we're talking about human scale drones, flying cranes, which need to prototype a lot and fast because they're at the beginning. They need to get to the final product to go in productions, and they need to iterate a lot. And they need, of course, to do flying tests. You cannot use PLA parts or printed parts because you want to use parts that are ultralight, like carbon fiber, but you don't really care about the quality, right? They don't need to be super shining. It's just about functionality. So here it makes sense to also use large format 3D printing, and in this case, you can directly print the mold. So as mentioned, on the left side, I will show you the two ways actually you can use large format 3D printing to manufacture carbon fiber parts, shining carbon fiber parts. So the first one is the one that Airflight is doing, so on the right, so more for prototypes. You can basically 3D print the mold directly. You can use height MCF. You post-process the mold. So of course you send it, you put waxing, everything that is necessary. And then you use that mold to manufacture your carbon fiber parts. So we suggest obviously to have a higher amount of infill, or even to fill the mold maybe with epoxy to make it stronger to pressure, because when you lay the carbon fiber parts, when you vacuum them, of course there is some pressure. Of course, you cannot heat it up to a high temperature. We're talking about, again, 100 degrees Celsius, 110 degrees Celsius. So the parts you get are not super high quality, but they're good enough to get prototype as a prototype and to check the design. And they are 70-80% cheaper than doing it with probably a CNC aluminum mold. Mostly, if you consider that we're talking about sizes here of like 1 meter, 1 meter, 1 meter. The second step, the second process instead is one step more, but you can get very high quality parts that you can actually be used for end production, like in the case of Xenons on the left. So what you do is you print the pattern or plug. It's called in different ways according with country, which is the positive, which is the part that you actually want in carbon fiber, right? So you print that one, you fit check it, you test it, and then if you decide to go with that design, you use that part to make a mold, which can be done, for example, in glass fiber, as you can see in the step 3 below. And then you can use that mold to make your carbon fiber parts. So that mold is not 3D printed, obviously, because it can resist to higher temperature and can actually be used for productions of high quality parts. Here it breaks a bit more the applications into step. So in this one is the case again where you want to print directly the mold for prototyping your carbon fiber parts. So top left is a BigRep Pro printing as a mold in height MCF. Second image, the print is done. You fill the mold to give it a bit more resistance to pressure. Third step, post processes and wax it. Fourth step, of course, lay the carbon fiber pre-preg in this specific example. then you vacuum seal it, you cure it, 100 degrees Celsius, you get your part. It's a very fast process, again, compared with other methodology, and you can do everything in-house, and you can have a small productions of part for your prototypes. Xenons, on the other hand, wants high quality part because customers, of course, they want to use it in their cars. So you print the part, the positive, the part you want to actually have in carbon fiber. You step one. Step two, you use that part as a prototype so the customer can already see how it looks and can give a go, no go. If the customer is happy, use that printed part to make a glass fiber mold or whatever other material might fit you. And then you can use that mold to make your carbon fiber parts that are obviously, as you can see in the image, very high quality. You can use them as a visual as well. Closing the chapter of carbon fiber reinforced plastic, another one where like mold and pattern, molds and patterns are very common. It's sand casting. In this case, obviously, we cannot print the mold because we're talking about melted metal, but printing patterns is very common. We have several customers doing it all over the world. I have two examples here. CJR metal casting. They do obviously propeller. So propellers, depending on the specific applications, but then they need to be customized. In this case, maybe accordingly with the yacht or the boat where they need to be assembled. So each of them can be different. They're big. So what customers do is using PLA to print the positive, the pattern, which then out of the pattern you can obviously make a sand mold and use that sand mold to make your metal parts. Right side is another completely different industry, but they use it for with the same application. So sorry, same industry but different applications. Australian Bell, obviously in Australia they make bells, obviously, and they really cut a lot the cost, both of this company, but in general in this industry, if you consider that patterns, yes, you can either handmade them in wood, which you can imagine is hard to find also the skills, or yes, you can CNC this like 1 cubic meter of parts to make a pattern. But first you need a very big CNC machine with various axes. But also there is other benefits, right? If you CNC blocks of wood, you still need to store that wood somewhere, or whatever material you're planning to use. You need to store it, and they're big, they're volumetric, and they're heavy. In this case, we're talking about additive manufacturing, so you really just need the filament, and then you can manufacture your patterns where you need them. As mentioned, the process is relatively easy. So yes, you print the pattern, and then out of the pattern you can make the sand mold, and then you just pour the metal to make your metal parts. Of course, I'm oversimplify the processes. It's not that easy if you are someone that is in the industry. There are some steps in between, but this is the concept, right? Another thing you can use is to actually use the pattern that you produce. You can as well, like usually a pattern, if you need to do a mass production or big productions, if you use a printed pattern, so we're talking PLA, so we're talking obviously a plastic, it cannot be used several times. After a while, it will start degrading with the pressure of the sand. But what you can do if you need to do a big production, you can use the part that you see in step 5, so the metal part that you produce out of the mold that comes from the printed parts, and that one you can CNC, so you really just clean the surface of the part that has already been made, and that pattern that is now in metal can be used for mass production. So you can save a lot of CNC machining, so you don't need to start from a big blank, but you can actually CNC the metal pattern that you made out of the plastic one. And so there is a lot of ways to go around, and again, it's very flexible, and that's what I believe is very interesting. Here other example of sand casting, JC Steele, Kennedy Valve, which Kennedy Valve is also in US, right? And they do a lot of hydrants, various designs, and they now print core boxes or patterns. Mezzo, Autotech, they have both a Pro and a One in Czech Republic and in Brazil. And you see, it's also very interesting. They do an hybrid. So let's say 80% of the pattern that it's always the same. They keep it in wood, but only the sections that they need to change, they do in printed parts. So they can really customize just assembling small pieces on the main wood pattern. Quickly, we go through also concrete formwork, which is another one in the mold industry. So obviously you can, this is relatively simple. It's just, you can obviously print the negative of the parts you need to make in concrete. Concrete is not too hot, or there is nothing that our filament cannot resist. So it's used quite a lot. On the left side, Giger is using it for restoring building. So they need to restore some elements, in this case an arch. So they had this existing, they had an example, the next window was already in place, so they were able to 3D scan the existing one, use the scan file to make the mold, and out of the mold they were able to pull down the concrete part on site, which is also very interesting, right? On the right side instead, it's for large scale concrete sculpture. I will show you a picture, PV Beton, here in Germany. What I like to highlight is that obviously you don't need to print everything. You can 3D print only the shape, and then you still use the wood to give the structure, let's say, so the resistance to the pressure. So you can build this hybrid formwork, right? So the 3D printed parts, as you can see also on the Giger on the left, is only the shape, but then you use the wood to make all those elements that can be structural. So you save time in 3D printing, and you can use flat pieces of wood. Here, just an image of the BB Beton sculpture that they made. So on the right side, you can see the sculpture and the sides. The buildings on the back gives a scale. So it came handy to use 3D printing, mostly in the section where there are a lot of triangles. So it gets a bit hard to make the full shape in wood. The last one in the mold and patterns is urethane. Also, urethane can be casted printing molds with BigRep machines. In this case, you can see CNU work with SAS, Scandinavian Airline. Scandinavian Airline needed during COVID some engine exhaust covers to basically keep, since the airplanes were not flying during COVID, but they were still, they were getting moisture, and then with the winter coming was not good for the airplanes, so they needed to build quickly these covers, and they needed to fit to several shapes. CNE, which is a local engineering company, jumped into support, and the guy was able to use his BigRep 1 and Studio to manufacture these large format molds that he used to pull up several of those covers in urethane. So he basically just printed the molds and then poured inside the urethane, the liquid urethane, which cures at reasonable temperature. So it was, let's say, a quick win. Obviously, there is a lot of engineers behind, but you can also find a video on our website where you can get more information. But another interesting applications where really someone who had access to a large format 3D printers was able to solve a problem very fast compared with maybe other manufacturing methods would have done. Last is end-use product, which a lot of people ask for. Of course, there are several ways to use large format 3D printing for end products. Also here we have different stories, different industry. On the left side, there is Magirus. They're using HeightMCF to customize some of their fleet of fire trucks. As you can see, the guy is holding a door open. That door from the fire truck, there is a bottom window that was not there before. So the guys at Magirus, they obviously have a fleet of fire trucks. That's what they manufacture. And they realized basically that only having the top window was not enough. They needed to have a window for the fire workers to be able to look down. So when they were jumping out of the fire truck, they knew exactly what they was expecting outside. So they were not risking basically to be injured or anything. So they needed to add an extra window on their trucks, and they were able to do this without actually outsourcing or sending, go back in production. They were able to customize because they had access to their own BigRep machine. So they were able to just cut it and build the frame to hold the glass in HeightMCF, the part that the guy is holding. So again, this is a part that they use for end, so as an end-use part. On the right side, Amazea instead is a startup here in Germany that manufacture those water jet scooters. So they are customized to the customer. So we're talking about mass customization here. From the day one, the owner of the company wanted to 3D print as much as possible. So the design has been optimized from the day one to be FFF friendly, let's say. So 80% of the part of the objects is basically printed between Pro HD, high temp, and TPU. For the flexible parts, of course, the electronic and other things, they cannot be printed. But it's very interesting. I think, if I don't remember wrong, at the moment he has 5 or 6 printers, BigRep ones, all of them in tandem mode, which means he split the print bed of 1 meter in two, so he can print 2 of those jet water scooter vertically at the same time. So he was able also to cut by half the production time. Obviously, he needs to post-process them to make them water resistant, etc. But he has developed his own technology to make sure that those printed parts can actually run underwater without being affected. They're very impressive, definitely. Others are like XEV, a company that is more and more, let's say, getting famous. They manufacture those electric cars, and they use our printer for both prototyping a lot for the design process. So they were able to optimize the design process, but also some of the parts can be customized of the car. So the user can decide, like those panels that you can see on the left picture. So they are able to do this using also 3D printing. So they don't need to change. Yes, they can have an X amount of parts that can be mass produced, but if someone wants to really customize them, they can simply 3D print them, and they don't need to go through, designing a full production line. Others are, and these parts are customizing vehicles, also the interior. This is something in US, we have a lot of customers doing it. So very straightforward. As you can see on the top and the bottom, there are 2 different companies. One is Fat Fender Garage and the other one is JK Automotive. So they both have a BigRep studio, and they use them to literally print parts that can use on cars. They maybe repair vintage cars, so they simply customize existing cars for customers. Before, we saw some exteriors from Xenon's UK with carbon fiber. In this case, is interior. So you can see they can print dashboards, they can print the console. The full console on the top is printed, which is pretty massive, as you can see. And then, of course, they do some upholstery, they do post-process, and they add leather, whatever the customer want, and they can set it in place. And this is really a lot of customization, which is wonderful. And one of the last one is design and architecture world. Obviously, here is where also a lot of end-use part can be printed. A lot of furniture with the generative design can be used. Also, you can use recycled filament. Like, as mentioned before, BigRep is an open system. So yes, we have our own filament, but you can freely test your own filament. So there is a lot of solutions now, for example, for recycled PET. So we have a lot of customers that are manufacturing furniture or design pieces with recycled filament. Or Studio Artefact, for example, on the right, they have 6 BigRep ones. They're based in Canada, and they really manufacture a lot of beautiful designs for events, for trade shows, for molds, or for general installations. I have a bit more picture from them here, for example. So these are all pieces from Studio Artefact. There is a giant frog that was for something in Las Vegas. I think it was Bellagio. Also, the Bellagio was also the one on the right. You can see the end frogs, so you can imagine how big is the thing. And in the middle is a sculpture that I did for Burning Man. They have 6 BigRep one. They love PTG. They only print in PTG because it's easy for them to post-process, to paint. But also we have other customers like CDM Studio in Australia that they manufacture a lot of pieces for museums, and again, installation in this case was for the Western Australian Museum. So they needed to rebuild their fleet of dinosaurs or other, let's say, animals or things that they need to exhibit. So Studio Artefact was able to take over the projects thanks to their BigRep to deliver also pretty fast. So they were able to just sculpt on their 3D model software like Blender or whatever they had, and then from the software just simply start printing the parts and then post-process. So you can see how huge those sculptures are. And if you compare with how those 2 companies were doing it before, obviously, which is a lot of like handmade, for example, working with clay and then post-process, now they're much more agile. Again, if a customer has some feedback and wants to change something, they can just model, change the model, and 3D print it again without going through the process of hand sculpturing, which obviously is a lot time consuming. You cannot do it all day and night. Same movie industry. Here is where our printer has been used for the First Man movie. As you can see, this was the printer that was in Hollywood printing some parts. And we have several customers, of course, also we cannot mention, but that they're using it for props or parts that can be used in movies. So this plus CGI, you can really unlock a lot of possibilities in the media industry. And the latest is research education. Obviously, these it's a bit like all of the one we saw before together, right? Accordingly, with the university focus, you can unlock a lot of applications for your students to actually, like start using new technologies to actually develop their projects. And we have dozens and dozens of universities around the world who decided to purchase a BigRep machine, also because, of course, access to funding, etc. Polyaero is in France, and they do very focus in the aviation industry, and they do a lot of mix of virtual reality and printed parts. On the right side, 1106, it's Helmut Schmidt University here in Germany, where they also do in Hamburg, where they use the printer for the Formula Students event. So they manufacture their vehicle with printed parts. I wanted to give you just a quick introduction to the printers we have at the moment in the market. So as you heard me mentioning BigRep 1 Pro and Studio before, the BigRep Studio and Pro are more our industrial line, let's say. The Pro and the 1 have in common the build volume. So BigRep 1 and BigRep Pro, it's a 1 meter, 1 meter. They're both 1 meter, 1 meter, 1 meter build volume, so 1 cubic meter. The Studio is the smaller sister of the Pro. It's a quarter of a cubic meter build volume, so 50 centimeter, 1 meter by 50 centimeter. While the BigRep 1 is more for research a lot, educations, or people who are now accessing the large format 3D printing. We obviously suggest the BigRep 1, which is much more accessible. While if you are already into large format 3D printing, maybe you want to start doing your productions of parts and you want the machines, to be more automated and have access to more materials, more high engineering material, then the industrial line kicks in and can help you.
Marco, are there any materials BigRep is working on that you were able to share?
We keep actually developing, obviously, like we keep, let's say, qualifying lots of materials. As mentioned, we are an open system, right? So first of all, we are always very much open to hear suggestions from our community or customers. If someone, needs something specific with some specific mechanical resistance, for example, or whatever, we can test it and we can see if we can qualify. From our side, yes, we are working on right now PA12CF, for example, which it will be released soon for the BigRep Pro and the Studio. So it's the next step of fiber field filament. It will be much more high temp resistance than temperature resistance than high temp, and much stronger filament. Very also much suitable for carbon fiber mold and patterns. We're working on different water soluble solutions to make sure that they fit for every applications. And obviously we are looking also into, for example, ESD filament, right? So also for these for production aids, it's something that our customers require a lot.
It was so great to learn about the molding applications and the end use parts. I had no idea that there are so many different companies out there using the BigRep technology for these types of molds. I really just want to talk about, how great this is about adding the BigRep into your existing workflow and how to help your business today to ease your supply chain bottlenecks, shifting the complexity of your system into the advanced technology of BigRep. Expanding the use of your large format 3D printing when you need to swap in and get parts fast. I just want to take a minute and offer to continue this implementation conversation offline, and to offer my services and time to you out there taking the time to listen to our webinar.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.